We're starting today with CSEC Mathematics. I am Latoya Shiraya, and assisting me is Brittany Henderson. For today's lesson, we will be focusing on writing numbers in expanded notation, expressing numbers to given significant figures, and writing numbers in standard form. Let's get started. All right, Brittany, here we have a scenario. Jane was having some difficulties naming numbers. So her teacher wrote this number on the board, 6,789. And Jane called the number 6789. In an effort to help Jane, her teacher wrote the number in expanded notation. What would this value look like in expanded notation? So you at home, you can write it down, try, and let's see if you remember what expanded notation looks like.
So, all right, let's take it to our place value chart. So we have 6,789, and let's just break it down into its components. So we have 6,000s, 700s, 8 10s, and 9 1s. Let's go again. So let's rewrite it. We have 6,000 plus 700 plus 8 10s plus 9 1s. This can also be written as 6 multiplied by 1,000 plus 7 times 100 plus 8 times 10 plus 9 times 1, which is just simply 6,000 plus 700 plus 80 plus 9, which is the same as 6,789.
This makes a lot of sense. Now, when I'm looking at the expanded form, I can just simply look at it and say 6,000, I'm seeing the 700, the 80, and the 9. So with expanding the number, that would have helped the, any student to easily call the number name, right?
Yes.
All right. Here is another example. So, Jane was shown this number on the board again by her teacher. 342 and 83 hundredths. And this time, Jane called the number 342.83. And we're going to use expanded notation yet again to help Jane in understanding how to call number names. So we're going to use the same strategy that Brittany spoke of just now. So the first thing we want to do is represent our number in our place value chart, just to be sure, you know, right? So we have 300s, 4 10s, 2 1s, and this time we have a decimal place. So we're moving into now our decimal place values, and we have 8 tenths and 3 hundredths. What would this look like in numerals? Okay, so we have 3 times 100 plus 4 times 10 because it's in the tens place, 2 times 1, 8 times 1/10, and 3 times 100th, just like how it's in the place value chart. And now we end up with 300 plus 40 plus 2 plus 83 hundredths. Thank you. All right, sorry. Okay, so now we're moving on to significant figures, and it's like, what? Okay.
Yes, not.
All right. So we have another scenario here. Our friend Trudy is a science major at Anorak Surif High. Get it?
Coronavirus high.
All right. She just completed her first chemistry lab and got her score. Her teacher deducted 5 marks from her final score because her answers were not written correct to the specified number of significant figures. However, Trudy, maybe like me, was very adamant that her answer was correct. So our job is to explain to Trudy where she went wrong and how to correctly write a number correct to a given number of significant figures. Now here are 2 examples from Trudy's work. So she had 3,487 she was supposed to write it to two significant figures, noted SF right there, and she had approximately 34, and then she had 3.605143. She should be writing it to four significant figures this time, and her answer was approximately 3.6051. Brittany, I think Trudy needs our help.
I think so too.
Yeah.
So first, let us start off by telling Trudy what exactly is a significant figure.
Okay.
Now, significant figures are numbers. Significant figures are the number of digits in a value, often a measurement that can contribute to the degree of accuracy. In other words, significant figures are used to make a measurement precise. Now, how is it that you determine if a number is significant? Well, all non-zero digits are significant. So digits like 4, 3, 2, 1, those are all significant digits. Any zero between significant digits are significant. So for example, 405. The zero in 405 is significant because it is in between two significant digits. Leading zeros are not significant. So for example, 023, the zero in front is not significant. Or 78 thousandths, the two leading zeros are not significant. Trailing zeros in a whole number are significant only if a decimal place is present. So for example, 4,500. The trailing zeros are not significant because there's no decimal point. And finally, a final zero or trailing zero in a decimal portion are significant. So let's take, for example, 0.230. The trailing zero here is significant because there's a decimal place, there are decimals present. All right, so Latoya, let's take this example.
Which is Trudy's work.
Yes, this is Trudy's work.
Okay,
yes.
and her answer for this was 34.
Yes.
Okay.
So let us help Trudy to correct this mistake.
Okay.
So how are we going to go about doing this? So Trudy's response was 34. So on our number line here, we're going to place Trudy's response. So Trudy's response was 34. Is this greater than 1,000 or less than 1,000, Latoya?
First of all, I'm seeing where, according to the definition of significant figures, is writing numbers precise or a measurement precise. So now Trudy's response, which is 34, is way off or far from the given number that she was supposed to write in significant figures.
That's true, because the original number was what?
3,487.
True.
Right. So what do I do next?
Okay, so here we have, we're partitioning our number line in thousands.
Okay.
Right? So we now need to locate where Trudy's response was, where our original number lies on the number line, and see how far off Trudy is with her response.
Far.
All right, so Trudy's very far. So 34 is less than 1,000, and we're dealing with 3,487.
Right.
Now let's make a distinction. How many significant figures do we have in 3,487?
4, because all non-zero digits are significant. So 4.
All right, so we're counting from the left, so that would be 4. You're correct. Now she's asked to round this number to 2 significant figures.
Okay.
So let's start.
So
how do we go about doing that?
All right, so you said starting from the left.
Starting from the left.
So that means that I want now 2 significant digits from my left, and the other digits should not be significant because I want the number to be to be written to 2 significant figures. So I'm seeing the 3,000 and the 400 in this number, or the 400s, the hundreds place rather, is where I would stop my significant figure.
Yes.
All right.
So the digits 3 and 4 are non-significant because, as we established before, all
Are significant.
are significant
Right.
because, as we established before, all non-zero digits are significant.
Okay.
So we're stopping at our hundredths place. Then we need to. Okay, so the 4 is
400.
400.
Right.
So what two places is 400 close to? What's the nearest hundredth?
Hundreds place. Okay, so that would be 3,400 and 3,500.
Okay, good.
Right.
Now, looking at the 87, so
Right.
87 is closest to what hundred?
Well, the entire 3,487, based on the number line, would be closer to 3,500.
That is correct.
Okay. Oh, and then the 2 zeros at the end would not be significant.
Because
in
those
this
are?
case, these are zeros.
These are trailing zeros.
Oh, trailing zeros, right. So that means that 3,487 written to two significant figures is 3,500. All right, I think I'm getting the hang of it.
Okay, good.
All right, here's another example from Trudy's work. So Trudy also had 3.605143, and based on her work, she wrote this to four significant figures as 3.6051. All right, so how do I go about writing this one to four significant figures?
All right, so let's start off by establishing where four significant figures would end. So we're going to start from our left again and establish
Okay.
all the digits that are significant.
Okay, so 3 is 1, 6 is 1, 0 is 1, and 5 is 1. So that means that my fourth significant figure would stop in my thousandth place,
Yes.
where the 5 is right now. And I'm looking at my digits to the right of that place to figure out which number is closest to this number, right? So I would like to think that then 3.605143 written to four significant figures is 3.605. In this case, the 0 will be significant because it's between two non-zero digits, right?
That is correct.
Okay, all right. And for you at home, we're going to give you just 3 to try on your own, and Brittany is going to take us through how we write these numbers into the specific number of significant figures. So the first one, 8,952
All
to
right.
one significant figure.
Okay, so let's go again. We're going to be starting from our left and establishing all the digits that are significant. So let's start off. What's the first digit that we have to our left?
8.
All right, so we're looking at the digit in our thousands place. So we say that 8 is significant, and then we're going to use the other digits that make up 8,952 to establish how close or how far it is from the nearest thousands.
Okay.
So it is going to be, 8 is significant, and it is close to 8,000 and 9,000. So how close is 8,952 to 8,000 or 9,000 if we wanted to approximate it?
Okay, so I'm thinking of the number line, and it's 8,952.
Yes.
That sounds near to 9,000 to me.
So 8,952 to the nearest, to one significant figure is
Right.
actually 9,000. And please remember here that our trailing zeros are
Not significant. So I'm only seeing one significant figure,
That's
digit
correct.
in this number.
That is correct.
Okay, all right. Now we have a 0.70451, and we need to write this number to 3 significant figures.
All right, so Latoya, we've been talking. Where would we start?
All right, I would start at the 7 because zeros to the front, what we call those again?
Leading zeros.
Leading zeros are not significant.
There we go.
All right. So my first significant digit would be 7. And I need to get to write it to 3 significant figures. So I would go 704. And this 0 is significant because it falls between 2 non-zero digits.
That is correct.
All right. So I'm going to stop at my 4. So that means that my last significant digit will be in my thousandths column, thousandths place, right? All right. So I'm looking at the 4 and I'm looking at the digits to the right of the 4, which is 5 and 1. So is it 0.704 or 0.705? Viewers at home, what do you think? What do you have on your paper? All right. If you had 0.705 or 705 thousandths, then you are indeed correct. All right. Next we have 6.3207, and we're supposed to write this one to 2 significant figures.
All right, so we're taking it to the left,
To the left.
All right, so starting from our left, is 6 significant? Yes, indeed. So 6 is significant in this case. So we're starting to count our significant figures. So it would be 6.3, and I'm going to stop there because I would have gotten 2 significant places, 2 significant figures. I'm going to use 207 to establish whether or not it's going to be 6.3 or 6.4? I wonder.
What do you think the viewers have at home? I'm putting a bet on the 6.4 people.
Boy, I'm thinking betting wrong though. But all right, let's see.
All right. Oh man, it's the 6.3 people.
I got this.
All right. So 6.3207 written to 2 significant figures is indeed 6.3. All right. Now we're gonna go a little bit into some standard form.
Oh wow, standard form.
Standard form.
Standard form, yes.
All right. What does that entail? But let's look at this scenario. So our little friend Trudy from science class, she found out that the sun is actually 149,600,000 kilometers away from the Earth.
Boy, Trudy, like research. Oh gosh, okay,
That's far.
wow, that's far.
All right, so Trudy wanted to share this information with her friends via WhatsApp. I don't know, tweeting it, I don't know. But then she found that this number was just too big for her to be writing over and over. So she asked her friend for a more concise, easier way to write the number. She was told that she could use standard form notation, but poor Trudy never know what standard form was all about. So let's help Trudy, and others who are not aware or they're not so sure how to write numbers in standard form. So of course, Brittany, just kind of take us through what is standard form.
All right, so standard form is a numeric expression.
Okay.
Right? Standard form is another way of saying scientific notation. So we're writing numbers in scientific notation.
So if I was told to write a particular number in scientific notation or standard form, is the same thing?
Yes.
Okay, cool.
So now we need to know how it is that we recognize a number in standard form. So
Okay.
this number is written in a particular way. If you hear it says scientific, so
Right.
it's scientifically written.
Okay, so this is like the general form that it takes.
Yes.
Okay, cool. All right. So this is saying that the first number, A, would be a number. And this is what the science people call the coefficient. Not like the algebra coefficient, really. But this is, the physics terminology, the science terminology. So the first number would be our coefficient. And this number must be greater than 1 or equal to 1, but less than 10. Let's go again. So this very particular number that will be here is going to be greater than or equal to 1, but less than 10. What are those digits that would fall in between greater than 1 and but less than 10? Greater than or equal to 1 but less than 10.
All right, so you're saying it must be equal to 1, right?
Right.
So I know the first digit is 1.
1.
So I know the first digit is 1.
Right.
You also said that it must be less than 10,
Right.
So let's write out all the digits greater than 1, but less than 10. So we would have 2, 3, 4, 5, 6, 7,
That 5.
8, and 9. Oh, wait, let me just rewrite my 5. You know, sometimes the handwriting. Okay, 5, yes.
You wanted us to rub out that one?
Yes, I'll erase it. I forgot about that, you know, thank you. Yes,
okay.
there we go.
So, or A would take, or A, the coefficient, could either be a 1, a 2, a 3, a 4, a 5, a 6, a 7, or a 8, or a 9. Okay, all right then.
Or any fractional number.
Or any fractional number. So it doesn't have to be whole number.
But as long as the decimal number includes 1, 2, so the whole number value
Right.
must be greater than 1, but it can also be 2.5 or 2.4 or
Okay, or 9.8.
there we go, but just
Okay.
not 10.
Okay, all right, got you. And then we have the multiplication sign. So after our coefficient, it's followed by the multiplication sign. And then we have a 10. This is the base, and this will always be 10, right? In standard form or scientific notation. And then we have our B, which is our exponent. So when we're writing in standard form, the 10 is always raised to an exponent, to a power.
Yeah, keep in mind that we're working within the base 10 place value system, so it's always going to be raised to some power of 10.
Okay,
Yeah, man.
all right.
So just remember
Cool.
that.
All right, so when we are writing a number in standard form, there are some questions that we must ask ourselves. This is what you told me. So we need to, 1, figure out where is the decimal point. Is there a decimal point? Is there not a decimal point in the number that we're trying to write in standard form? And 2, does the number meet the requirement of the coefficient? And we said that the coefficient must be greater than or equal to 1, but less than 10. Okay? And then we want to know now, can we multiply or divide this number by any multiple of 10, 10, 100, 1,000, or power of 10 rather, not multiple, but power, to give a suitable coefficient if we don't have one.
Yes.
All right, Brittany, take us through this one. I want you to write 8,765 in standard form. And I'm going to take us through the questioning. So our number is 8,765. And let's go through the questioning now. Where is the decimal point in this number?
That's why I don't see a decimal point.
There is no decimal point, but can we rewrite this number to include a decimal point?
I could rewrite it to include a decimal point.
Okay.
My point is right there.
So it's tiny, but we're seeing it. It's a little tiny. There you go. All right. So the next question is, does the number meet the requirement of a coefficient?
So, what I heard you say earlier, and I think we both said it, is that the coefficient must be equal to 1 but less than 10. Equal to 1 or greater but less than 10.
Yes.
Right?
And this is...
And this is 8,765. So that is way bigger
past 10.
than 10.
So
So what can we do now?
then, okay, so I'm going to look at the next question, which is, can we multiply or divide this number by 10 or any power of 10 or multiple of 10 to get a suitable coefficient?
You know, I think we could, but I'm not sure of what power of 10 to divide by. So
let's
guess
start
what?
with 10.
Yeah, I'm going to just try and
Yeah, let's
see.
start with
You know,
10.
Let's start and try.
So 8,765 divided by 10, point 0. Point 0, don't leave it out.
Oh, my bad. Sorry.
All right. You're 5 though.
Sorry. You know,
And
sometimes.
you forgot the 0 again.
Oh.
What? Okay, it's fine. All right. So we know how to multiply and divide by 10 easily. So that would just be 876 and 5/10. All right. We still don't have the suitable coefficient, so I think we should divide again. Do we want to just write equal here?
Pardon me?
Equal this line? Let's write, okay. Equal the 876.5 and 5/10. This board.
Okay. So if we divide 876 and 5/10,
Wait.
we would get 87 and 65 hundredths.
Still not matching to the coefficient. That's still bigger than 10.
Okay, so I'm going to divide another time. So I'm going to divide again by 10.
Okay.
So now what we're going to get is
8 and 765 thousandths.
my decimal point is not. Okay, you can see it a lot better now. So now we have,
You have 0 and not divide by 10.
oh,
All right. So now I'm seeing that we have a coefficient. So that's the first thing. We have the coefficient, which is 8 and 765 thousandths, or 8.765. The next step, I remember there was a multiplication sign.
so
now
we have to now write it as something multiplied by a power of 10. So
Okay.
we've gotten our coefficient,
Okay.
right? So our coefficient is 8. Please forgive me. 7.
Smart.
Okay.
You want to try the smaller point? Right. All right. And then?
It's being multiplied by some power of 10. Now, in this case, we divided by 10 3 times.
Right.
And if we're doing something over and over, is there any sort of precise way that we could write that mathematically?
That's how we have the exponent.
Oh,
Right.
okay. So it is, so since we divided by 10 3 times, my exponent is then going to be what?
3.
Because if I multiply 8.765 by 10 to the third power, which is the same as saying 1,000, it's actually going to equate back to 8,765.
So we're just doing the reverse. The inverse of multiplication, which is inverse of division, which is multiplication, to get back our original value.
Yes.
Okay, so indeed, that's what we had here. 8.765 times 10 raised to the third power. And just checking. All right, so the coefficient is there, check.
Nice.
Multiplication sign is there, check. Our base is there, check. And our exponent is there, which is correct. All right. I hope, viewers at home, you were paying attention. We want you to try this one on your own now. So we're going to give you 2 seconds, 5 seconds, 10 seconds.
Your second's long though. I think time up.
Okay. All right. So remember, the first thing you want to do is ask yourself the following questions. Where's the decimal point in the number? Does the number have the required coefficient? Is the number greater than or equal to 1 and less than 10? And can you multiply or divide this number to get the coefficient where we would want it to be? So what would we do in this case now, Brittany?
All right, so as you can see here, Latoya, is the first number that we had was much larger than 10.
Right.
This digit that we have, is it larger than 10?
It's actually less than 1.
Okay, so here we have a smaller number.
Right.
All right. So if we have a smaller number and it is that we want to know, rewrite this number or find a coefficient that is somewhere equal to 1 or greater but less than 10, how do you think we could do that? What are the other questions that we should have been asking ourselves again, Latoya?
So we want to know, does the number meet the requirement of a coefficient?
So we've established that no.
Okay, can we multiply or divide this number by 10, 100, 1,000 to get a suitable coefficient?
All right. So before we divide it, and because we want to get larger, I'm thinking that, boy, I should multiply, right? Okay. So we're multiplying again by powers of 10. And viewers, forgive me, but I'm not so sure of what power of 10 to multiply this number by. So help me out now.
Or let's just go by 10 each time.
All right, fine. That sounds like a good plan.
Yeah.
All right. So I'm going to multiply by 10. So if I multiply by 10, what will the answer be?
0.01287.
All right. Is that anywhere near to 1?
No, I think
but
we're getting there again.
Yes. So let's multiply by 10 once more.
Okay.
What am I going to get now, Latoya?
0.1287.
All right, I'm still not at 1, so what am I going to do again, Latoya?
Multiply by 10 again.
All right.
And now we have 1.287.
Now, is that anywhere? Is it 1? Is it more than 1? Is it less than 1?
A little bit more than 1.
So it's
I
just
think
a
we
little
can
more.
use this.
Okay.
All right. And I now realize that we would have multiplied 3 times by 10.
So my coefficient is 1.287, but I multiplied this time by powers of 10. So instead of multiplying, so since I multiplied, my index is now going to be?
Negative.
Negative, because in truth, the real value of this digit was 0.001287. So if I multiply by a 10 to a negative index, it's the same as saying?
Dividing.
It's the same as dividing. So I'm dividing by 1,000th with the TH.
Right. So it's the inverse yet again.
Yes.
Okay, so here's our answer, as Brittany showed us. 1.287 times 10 to the negative 3.